Think about the sound that fills your world. It's the soundtrack to your life, the beat of your city, the voice in your home. It's absolutely everywhere. But have you ever stopped to wonder what it takes to bring that sound to life? What incredible journey of engineering, force, and precision turns raw, silent materials into an instrument that can actually move you? The answer doesn't start in a music studio. It starts right here, in the fiery heart of a mega factory. From metallic dust to the final thunderous sound test, this is the untold story of how millions of speakers are made. It all starts with the force of nature, harnessed and controlled. Magnetism. And inside these massive industrial furnaces, the journey to create the engine of the speaker begins. A carefully measured recipe of minerals, mostly iron oxide for common ferrite magnets, or a potent blend of rare earth metals for high-performance neodymium magnets, is prepared. This metallic dust is the seed, the raw potential for a force that will soon move air and create music. The process is a torrent of controlled violence. The mixture is compacted under immense pressure and then baked at blistering temperatures, often exceeding 2000 degrees Fahrenheit, forging it into the very heart of the speaker's motor. Chapter 1. The core of the sound. Forging the driver components, the magnet, the unseen engine. The creation of a speaker magnet is a wild mix of material science and brute force. For ferrite magnets, the workhorse of the industry, a powdered mix of iron oxide and other elements is milled into an incredibly fine dust. This powder is then dumped into a massive press, where a die slams down with immense pressure, compacting it into a dense, solid blank. These blanks, still brittle and completely unmagnetized, are loaded onto huge trays and sent into a long, tunnel-like kiln for a process called sintering. Inside that kiln, for hours on end, the temperature is precisely raised to just below the material's melting point. This extreme heat fuses the individual particles together, forming a solid, dense ceramic-like object. This is what gives the magnet its strength and permanent magnetic properties. After a slow cool down to prevent cracking, the magnet is still just a specially shaped piece of metal. It doesn't have any magnetic charge yet. The final, most dramatic step is magnetization. The sintered blank is placed inside a powerful coil. For a split second, a massive pulse of electricity, we're talking thousands of amperes, surges through the coil, creating an insane electromagnetic field. This jolt instantly aligns the magnetic domains inside, transforming it from an inert block into a powerhouse of invisible force. This is why neodymium magnets, which are way stronger and lighter, allow for smaller, more powerful speakers. They're just more expensive and can lose their magnetism if they get too hot. Ferrite magnets are bulkier but cheaper and more stable, which is why you see them everywhere. The diaphragm, the voice of the speaker. If the magnet is the engine, the cone, or diaphragm, is the voice. This is the part that will physically push air to create sound waves. Choosing a material here is a delicate balancing act. You need something light for a quick response, stiff so it doesn't bend, and with good damping to stop it from vibrating when the music stops. For decades, the champion material has been one of the oldest, paper. But this isn't the paper in your printer. It starts as a pulp, a slurry of wood fibers, water, and other secret ingredients like cotton or wool, all mixed in giant vats. This recipe is a closely guarded secret because it defines the speaker's unique sound. This pulp gets sucked onto a fine mesh screen shaped like a cone. As the water drains away, a delicate, damp layer of paper fibers is left behind. This fragile cone is then carefully moved to a heated press, where it's dried and compacted into its final, familiar shape. In a parallel process, plastic cones are born from heat and pressure. Polypropylene is a popular choice because it's tough, consistent, and water-resistant. making it perfect for cars or outdoor speakers. Tiny plastic pellets are melted down and then injection molded into a precise cone shape. For high-end audio, the factory turns to more exotic stuff. Aluminum cones are incredibly rigid and light, great for reproducing high frequencies with stunning accuracy. Then there are woven composites like Kevlar, the same stuff used in body armor. It's incredibly strong and light, which means extremely clear sound. These high-tech materials are expensive, so they're usually reserved for top-tier systems. But no matter the material, every single cone is scanned by lasers to make sure it's absolutely perfect. The voice coil, the electrical heart. Hidden deep inside the speaker, the voice coil is what turns electricity into movement. It's basically a tiny, powerful electromagnet. The process starts with spools of incredibly fine wire, usually copper for its great conductivity. This wire is fed into a high-speed, automated winding machine that holds a small, hollow cylinder called a former. As the former spins at thousands of RPM, a microscopic layer of adhesive is applied. The wire is guided onto it with robotic precision, making sure each turn lies perfectly next to the last, with no gaps. A perfect winding is critical. Tiny mistakes here can create audible differences in how the speaker sounds. For more powerful speakers, multiple layers of wire are wound, with heat-resistant epoxy applied between each layer. The finished coil is then baked in an oven. This cures the whole thing into a single, solid, and incredibly tough unit that can handle the intense heat and violent vibrations of making music. Chapter 2. Assembling the driver, a symphony of precision. The suspension system, controlling the chaos. A speaker cone has to move back and forth with incredible speed, sometimes thousands of times a second. But that movement can't be sloppy. It has to be perfectly controlled. That's the job of the suspension system, made of two parts, the surround and the spider. The surround is that flexible ring you see connecting the cone's outer edge to the speaker's frame. It's usually made of rubber or a special foam stamped out of large sheets by a press. The surround has to be flexible enough to allow for deep bass notes, but also firm enough to pull the cone back to its starting position in an instant. The second part is the spider. It's a wavy, circular piece of treated fabric that sits at the base of the cone. It acts like a spring, keeping the voice coil perfectly centered in the super-narrow magnetic gap. If it shifts even a little, the coil will rub, creating distortion or even destroying the speaker. The spider's fabric is soaked in resin and then heat-pressed into its signature corrugated shape, a design that lets it move up and down, but not side to side. Together, this suspension system is the unsung hero that keeps the speaker's motion clean and linear. The Trinity assembly: cone, coil, and spider. Now the core moving parts have to become one. This is one of the most critical steps, where the cone, voice coil, and spider are joined together into what's called the cone assembly. It's all about alignment. A special jig holds the cone perfectly centered. A robotic arm carefully lowers the voice coil into the neck of the cone. A dispenser applies a bead of high-strength, heat-resistant adhesive right where they meet. This bond has to be insanely strong, since all the force is transferred through this one joint. Almost at the same time, the spider is brought in and glued to the voice coil. This whole trinity, cone, coil, and spider, is now a single unit. The assemblies are then carted off to large curing ovens and baked, cross-linking the adhesives into an unbreakable, permanent bond that will survive a lifetime of abuse. The motor system, uniting magnet and frame. While the cone assembly cures, the stationary part of the speaker, the motor, is being built. This starts with the frame, or basket. For most speakers, this is stamped from a sheet of steel. For high-end speakers, it's often a cast aluminum frame, which is much thicker and less likely to vibrate and color the sound. The magnetic motor itself is usually made of three pieces: the main magnet, a top plate, and a back plate with a raised center called the pole piece. These iron plates are fantastic magnetic conductors. An industrial adhesive is applied, and the pieces are stacked and bonded to the back of the speaker frame. The top plate and pole piece are designed to create a very narrow channel between them. This is the magnetic gap, and it's where the voice coil will live. The magnetic field is focused right into this gap. The precision here is measured in fractions of a millimeter. If the gap is too wide, the speaker is inefficient, too narrow, and there's no room for the coil to move. It's a space of pure potential, just waiting for the voice coil to arrive. Chapter 3. The body of the speaker, crafting the enclosure. The wooden cabinet, acoustic carpentry. The driver is the heart, but the enclosure, or cabinet, is the body. And it does way more than just hold the driver. It's a critical part of the sound. For most speakers, the material of choice is MDF, or medium-density fiberboard. The process starts with massive sheets of MDF. It's chosen because it's incredibly dense, stable, and acoustically dead, meaning it doesn't vibrate and resonate along with the music, which would just add a muddy sound. These large sheets are loaded onto a CNC router, a huge automated cutting machine. Following a digital blueprint, a high-speed bit carves out all the panels for the box, including the perfectly circular holes for the drivers. The precision of the CNC is everything. Even a tiny gap in a joint can cause air leaks, creating whistles and killing the bass performance. Once the panels are cut, they move to the assembly line. Workers apply high-strength wood glue to the edges and join them. Pneumatic clamps hold the box under immense pressure while the glue sets. Inside, additional pieces of MDF are often installed as bracing. These braces connect opposite walls, making the cabinet even more rigid. Without bracing, a speaker cabinet can act like a drum, adding its own unwanted tone to the music. The plastic enclosure, mass production. Perfected for a lot of modern speakers, especially portable Bluetooth models and smart speakers, wood is just too heavy and expensive. This is where the factory relies on injection molding. It all starts with a mold, a massive block of hardened steel that's been machined into a negative of the speaker's design. This mold is loaded into a colossal injection molding machine. Plastic pellets are fed into a heated barrel and melted into a liquid. Then, with incredible force, a piston injects this molten plastic into the mold's cavity, filling every nook and cranny. Cold water is pumped through the mold to rapidly cool the plastic. Seconds later, the mold opens and ejector pins push out a brand new, perfectly formed speaker enclosure. The whole cycle can take less than a minute, allowing the factory to churn out thousands of these every single day. Acoustic treatment, taming the beast within. A speaker driver pushes sound out the back as well as the front. That backward sound wave can bounce around inside the box, creating echoes that interfere with the new sound coming out. This can make a speaker sound hollow and unclear. To fix this, the factory has to tame the beast inside the box. The main weapon is acoustic damping material. Workers take large rolls of fluffy synthetic fiber, like the stuff in pillows, or specialized acoustic foam and line the internal walls of the cabinet. This material works by absorbing the sound energy, converting it into a tiny amount of heat. The placement and amount of this material are carefully calculated by engineers. Too little, and the sound is a mess. Too much, and you can kill the bass. It's a crucial step you'll never see, but you'd definitely hear if it was missing. Chapter 4. Final assembly. The speaker is born, integration, drivers, wires, and crossovers. This is where it all comes together. The finished enclosures arrive at the final assembly line. The drivers, woofers, tweeters, and mid-ranges are ready. First, a soft foam or rubber gasket is applied around the driver opening to ensure an airtight seal. Then, workers or robots carefully place the drivers into their openings and secure them with pneumatic screwdrivers. Now for the wiring. For complex speakers, a critical piece of electronics is required: the crossover. Think of the crossover as a traffic cop for the audio signal. It's a circuit board that takes the full signal and splits it up, sending only the high frequencies to the little tweeter and the low frequencies to the big woofer. This is essential because a tweeter would be instantly destroyed by a heavy bass note, and a woofer can't move fast enough for delicate high notes. Workers solder the wires from the crossover to the terminals on each driver. Every connection has to be perfect. Sealing and finishing touches. With all the parts installed and wired, the enclosure is sealed up. The back panel is glued and screwed into place, creating a completely inert, airtight acoustic chamber. Now, the only sound that can get out is the good stuff from the front of the drivers. Finally, the finishing touches are applied. A fabric or metal grille is snapped on to protect the drivers. The input terminals are installed on the back, and at last, the company's logo is carefully applied to the front. The speaker finally looks like a finished product. But its most important test is still to come. Chapter 5. The moment of truth. Quality, control, and testing. Every single speaker that comes off the line has to prove itself. The QC section of the factory is a gauntlet of tests designed to catch any flaw. First, each speaker is hooked up to a station that runs electrical checks, making sure the voice coil is perfect. Then comes the first listening test. An automated system plays a rapid sine wave sweep, from the lowest bass to the highest treble. Microphones capture the sound, and a computer analyzes the frequency response, comparing it to a perfect golden reference model. Any speaker that deviates is immediately rejected. This test also catches any buzzing or rattling from a misaligned part. But for a truly accurate measurement, you need a room with zero echoes. For this, the factory uses an anechoic chamber. It's one of the quietest places on Earth. The walls, ceiling, and even the floor are covered in massive, sound-absorbing foam wedges. Any sound that hits a surface just dies. Inside, a sample speaker is placed on a stand in front of a calibrated microphone. A computer analyzes the pure sound of the speaker with no interference from the room. Some speakers even get subjected to a brutal endurance test, blasted at high volume for hours or even days to simulate a lifetime of heavy use and expose any hidden weaknesses. Chapter 6. From factory to living room, packaging and logistics. Only after passing this battery of tests is a speaker worthy of leaving the factory. It gets a final cleaning and polishing before entering the last stage. Packaging. A robotic arm places the speaker into a custom-molded cradle made of cardboard or foam, engineered to protect it from shocks during shipping. Manuals and warranty cards are added, and the whole thing is sealed in a heavy-duty box. At the end of the line, a palletizing robot stacks the boxes onto a wooden pallet with geometric precision. A wrapping machine then encircles the pallet in layers of plastic, filmed to create a stable load. These pallets are moved by forklift to a vast warehouse, waiting to be loaded onto trucks, trains, and container ships, beginning the final leg of their journey to retail stores in living rooms around the globe. So, from a fiery furnace and a vat of paper pulp, through a dizzying dance of robots and human skill, a speaker is born. The whole process is an incredible symphony of modern manufacturing, turning silent matter into a vessel for music and voice. And as these millions of speakers ship out deep inside the factory, the process has already started all over again. Because tomorrow, the world is going to need millions more. If you loved seeing how things are made, make sure you subscribe and hit that notification bell. You won't want to miss where we're going next.